The postsynaptic neuron releases neurotransmitters into the synapse. This neurotransmitter diffuses to the synapse until it finds receptors and ligand gates to bind to. Once it binds these ligand gate receptors, this causes sodium ion channels to open up, which allows sodium ions into the neuron. The more neurotransmitters there are, the more they can bind to these receptors in the ligand gates, and this allows more potassium ions in. This is called a greater response because based on the number available and not reaching a certain threshold or anything like that. As the sodium enters the cell, it messes with the resting membrane potential. The resting membrane potential is normally at negative 70 millivolts. With the addition of the positive charge from the sodium, though, this number increases to like negative 69, negative 68. And it just can keep going up and up and up. Or if inhibitory stimuli occurs and opens up negative ion channels, it can bring this number back down to negative 70 or even lower than negative 70. The important thing is that if it keeps going up and up and up, it can reach something called threshold. Threshold is negative 55 millivolts, and this is the point of no return. At this point, it can no longer go down, it can only go up, and at negative 55, voltage-gated channels open up, opening sodium channels in the axon hillock, allowing sodium ions to flood into the axon hillock, quickly depolarizing the membrane, causing the membrane potential to shoot up to positive 30 millivolts. One of the things that happened back here at the negative 55 millivolts is that the potassium ion channels start to open up too. The difference is that the potassium and ion channels open up a lot slower than the sodium ion channels. So they don't really open up all the way until it gets to positive 30. Positive 30, they open up. Potassium floods out of the cell. This repolarizes the membrane and starts kind of a chain effect. So getting the action potential down the axon happens in fast segments, creating like a domino effect. To reach threshold, it takes a combination of excitatory and inhibitory stimuli occurring until there's enough more excitatory stimuli than inhibitory stimuli so that they can reach this negative 55 millivolt threshold. Like I said, at negative 55, both these channels open. This one just opens up a lot faster, flooding the axon hillock, depolarizing the membrane to positive 30. The slower potassium channels catch up, it repolarizes, and the process of repolarizing this segment, it causes the next segment to reach its threshold, opening up sodium channels, allowing sodium to flood in. It depolarizes the membrane up to positive 30. Positive 30, the potassium channels catch up. The potassium goes out, causes the next segment to open up its sodium channels. Sodium comes in, reaches positive 30, releases the action potential again. The can't find the right color, but yeah. The potassium opens up, goes out, and it keeps going and going until it reaches the end of the axon terminal end. The action potential then will trigger the opening of voltage-gated calcium channels. Calcium comes in, causes the vesicles inside the synaptic end bulbs to fuse with the plasma membrane and release neurotransmitters into the next synapse. Now to get a closer look at membrane potentials, this is where I was talking about the sodium gates being open with the ligand gates. So with excitatory stimuli, the membrane potential goes up, with inhibitory goes down, and it keeps going up and down until there's enough excitatory stimuli to kind of outdo the inhibitory one and get the membrane potential up to negative 55 or threshold. At negative 55, the voltage gate opens up. Sodium ions flood into the cell, depolarizing the membrane up to positive 30. Positive 30, the action potential is released. Also at positive 30, the potassium ion channels that start opening up at threshold are finally open enough that potassium can come out and repolarize the cell. They do such a good job of repolarizing the cell that they actually hyperpolarize the cell membrane and cause it to go below resting potential of negative 70 to negative 80. And at this point, there's more potassium outside the cell than there should be, and there's more sodium inside the cell than there should be. And to fix that, they use the cells use sodium-potassium pumps to pump the potassium back in the cell and the sodium back out until it reaches resting membrane potential.